Hi everybody, this video is correlation and regression, scatter plots and regression equations. So first we're going to look at a couple vocabulary words. The first word is correlation. So a correlation exists between two variables when the values of one variable are somehow associated with values of another variable. So basically we're trying to see if two variables are related. So we may use words like associated or related when we talk about correlations. The next word we want to look at is regression. And regression is actually an equation that describes the relationship between the two variables. And so that's what we're going to be talking about in this section. So let's take a look at this example. So there's quite a few things going on this screen. So if you look over here, we have home prices and we have a table of values. So on the left side, we have the size of the house in square feet. So we've got a house that's 2,521 square feet, another that's 2,555 square feet, so on and so forth. And then we have these prices of each of those homes in thousands of dollars. So this number 400 actually represents 400,000. We just truncated a little bit to make it easier to work with. So we can see that this house that is 2,846 square feet costs $435,000. So basically, this is a table of values. You can see over here that we have plotted each of those houses as a point. So if we look here, this point here is the house that is 2,521 square feet that costs around $400,000. So do you see that right here? It's lined up with the size of 2521. And then if you look this way, it lines up with 400,000. And so then we have corresponding points for every one of the houses that are represented over here in this table of values. So this right here is called a scatter plot. When you plot those ordered pairs, the x-axis is your independent variable. It's also we also call it a predictor variable. And then the vertical axis, the y-axis, is the price. We call that the dependent variable. So this is what it looks like in graph form. So let's notice a couple things. We're noticing that x is the size, again, the independent variable, y is the price. The x value, which is size, will predict the price. So that's where the predictor variable comes in. And so if you look at the points, you can tell they're trending in a certain direction. The farther to the right we go, look what's happening to the points. They're going up. So it looks like they're kind of grouped around a straight line. So if you follow my little blue dot, I'm drawing a straight line that these points are kind of trending around. So let me do something like that. I'll just draw a dotted line there to represent that. But those points are kind of trending in that direction. And so the larger the house is, it looks like the price is definitely increasing for those larger houses. So smaller houses cost less or tend to cost less than the larger houses. It's not a perfect straight line, but that looks like basically what it's trying to show us. So we have an association. Another word for association is the word we learned on the first slide, which is correlation. All right, so two variables have a linear association or correlation. We're going to use those words interchangeably. If the scatter plot shows the data clustering around a straight line, such as what we saw up here, they're clustering around this imaginary straight line right there. Two variables have a positive association if the larger values of one variable are linked with larger values of another. So if we look here, the larger house size or high house sizes rather are linked to the higher house prices. So that would be a positive linear correlation or association. Also, and this I think comes up on another slide, but we'll say it here too, they're trending in the upwards direction. So if it's trending as you're going to the right, if it's trending upward, then it's usually a positive association. Whereas if you were going down as you were going to the left, that would be a negative association. So which brings us to this next point here. Two variables have a negative association if larger values of one variable are linked with smaller values of another variable. So as one variable gets bigger, the other one gets smaller, and so that would have points that were trending in a downward direction, kind of like what I just drew there. So this is some pictures of what the positive and negative correlations look like. So with the positive, if you'll remember what it said that larger x values, so larger x's are associated with larger y's. So again, the points tend to be moving in the upward direction. So as we move to the right in the positive direction, the points are getting higher and higher in the positive direction that way. Now, if we have a negative linear correlation, remember that is when the larger x's are associated with smaller y's. So you can see here, as we're going to the right and the x's are getting bigger, look what is happening to the points. They're getting lower and lower and lower. So as the x is going one direction, in the positive direction, the y is going in the opposite, in the negative direction. Okay, and then we have when there doesn't seem to be a trend or a pattern at all. So I can't really make out kind of like a line that these points are kind of following. So you can also have a weak correlation. And so that's when there is no strong association. They're not really trending about a line at all. They're just kind of a blob of points. So that would be a weak correlation. Now, the stronger the correlation, the closer the points will make to a straight line. And then the weaker the correlation, the farther away from a straight line that they are. And so real quick, I meant to delete this because we're not using the calculator to calculate this. So we're going to go ahead and move down to this slide here. There's something called a correlation coefficient. A correlation coefficient. And what a correlation coefficient is it is represented by the letter R, lowercase. And it's the measure of how strong of a linear relationship is between two variables. So there is a formula for it, and if you look, that formula looks crazy, right? So I've introduced the formula, but we're not going to use it, okay? So we are not using the formula. we are actually going to find the correlation coefficient using technology. Yay! All right, so I'm going to show you how to find it, but first let me explain to you what this R represents. Again, it is measuring how strong a linear relationship is between two numbers, but what does that look like in number form? Okay, so here are the properties of the correlation coefficient that that you should know. All right, first off, the correlation coefficient can range anywhere from -1 to +1. All right, so it's not going to be any smaller than -1. It's not going to be any larger than +1. And normally it's in between. So normally it's a number in between. And regardless of whether we call X or Y the independent variable, no matter which way you do it, if you do have X as X and Y as Y or vice versa, the R is going to be the same. Also, the correlation coefficient only measures the strength of a linear association. If you were to go into some more advanced statistics classes, you would talk about other types of correlations. There's nonlinear correlations. In addition to linear correlations, we're only focusing on linear correlations. And the R, specifically the correlation coefficient, only measures the strength of the linear association, the linear correlation, not any of the other types, which is fine for us because, again, we're not going into those other types of correlations. So here is the deal, though. This is really important. If R is positive, that means the association is positive. That means that you have points trending upward. And then if R is negative, the association is negative. And so in that case, we would have points trending in the downward direction like that. All right. So the sign, positive or negative, of the R is a tell on which way the points are trending. Okay, so other properties. Okay, so the number that you get. So we know if it's a positive number, it's a positive correlation. If it's a negative number for R, it's a negative correlation. But what do the numbers themselves mean? And so basically, the closer a number is to 1, or the closer it is to -1, the stronger the correlation. So if we had something like, oops, R equals 0.89. So 0.89 is pretty close to 1. So like if we were looking at a number line, and here's 1, here's 0, here's -1, and let's say we have 0.89. 0.89 would fall somewhere over in this direction. 0.89. You can see that's pretty close to 1. So the closer it is to 1, the stronger the relationship it is. So this would be saying if you have an R, a correlation coefficient of 0.89, that would mean that it has a strong correlation, and the correlation is positive. So it would be a strong positive linear correlation. If you had R equals -0.92, where does that fall? So that falls maybe really close to -1 right here. So see how that is really close to -1? So that means it has a strong, in this case, negative linear correlation. And then, of course, we can have numbers that are not so close at all to 1 or -1. So let's say we have R equals 0.25. So where's that? So 0.25 is positive. It's halfway between 0 and 1/2. So I would say it's probably about right here. And so see how that's closer to 0? So that would have a weak, sorry about that. That would have a weak linear correlation because it's closer to 0. So again, the closer it is to 1, the more those points are going to line up. So like if you had a linear correlation of +1, those points would line up in a perfect straight line. So the closer it is to 1, the stronger the correlation and the stronger the points are into making a perfect straight line. So again, if R is close to 0, there's a weak correlation, but if it's actually 0, then there's no linear association or correlation at all. And then the value of R, this is important, the value of R is not connected to the value of the slope aside from the sign. So a positive slope would have a positive R, but the numbers would not be the same unless it was some coincidence. And if it had a negative correlation, you would have a negative slope. So negative R, negative slope as well. But again, the numbers wouldn't be the same. The only thing that would match up would be the sign. And then something we're going to learn about is outliers. We're going to learn about those later. But just really quick, I'll tell you that they are considered extreme values when you compare it to the rest of the data. And so sometimes these extreme values can affect some of the statistics that we are calculating. And so correlation coefficient is affected by those outliers. So that's something to keep in mind for later. All right. What else do we need to know? This is just kind of reiterating what I just said in that last bullet point. When we say that a correlation coefficient is not resistant, that means that it is not resistant to those outliers. So if you have outliers, those extreme values, they will affect the correlation coefficient, and therefore the correlation coefficient could be a little bit misleading if those outliers are indeed part of the data set. The other thing that's important to note is just because two things are related, it doesn't mean that one causes the other. So correlation is not causation. That's important to note. So let's go back to the house price example. So I'll just go ahead and show you now. I haven't shown you how to find it yet, so no one panic. All right. But the R in this case is 0.9006. All right. That is the R in this case. And again, I'll show you how to calculate that in a moment. So since R is 0.0, I'm sorry, I'm writing this wrong, 0.9006, if you were looking on a number line, 0.9006, somewhere really close to here. That's really close to +1. So we would say that this is a strong positive linear correlation. All right, again, I will show you how to find R in a moment, but I wanted to just first focus on what R is showing us. Okay, so R is close to 1, so we've got a strong positive correlation. That means that the size of the house is related to the selling price. Typically, what we were seeing earlier is that the size of the house, as it got bigger, the selling price got higher. Now, we need to remember that just because they're related doesn't mean that one causes the other. So what that means here is they are related, and the size probably has somewhat something to do with the selling price, but it's not the only thing that has to do with selling price. And I'm sure if you thought about uh, big houses and small houses and their prices, you can probably think of some reasons why some houses that are larger will cost more than other houses of the same size. For instance, if we look here, oops, if we look down here at this house here, there's two houses that are the same exact size, 3198, and one of them costs 488,000 and the other costs 455,000. So the question is, why don't they cost the same? Now they're both some of the higher prices, especially the 488. But they're not exactly the same price. So there are other things that come into play. So what are the amenities in the house? How old is the house? How taken care of was the house? Does it have a new roof? How old are the appliances, like the water heater and the dishwasher? Do things need to be replaced? What do the cabinets look like? Does it have air conditioning? If so, does the air conditioning work? How big is the yard? What is the neighborhood like? Etc., etc. So there are many things that go into selling price. Size is only one of them. So that goes back to the correlation is not causation. So just because two things are related doesn't mean that one causes the other. Um, now, now that we know that these are correlated, we're going to explore that other vocabulary word we learned, which was regression. So if we want to figure out what kind of relationship that the two variables actually have, we can figure that out by finding the regression. Saying this the long way, it's called the least squares regression line equation. I just call it regression equation for short. I want to go ahead and put this out there. You may also see it called the line of best fit, but I usually call it regression or regression equation, but I just want to put all three of these out there. You can hear it called least squares regression line, or regression equation, line of best fit. All of those mean the same thing. But that equation will show the relationship between the variables. It will model it. So that is what we're going to learn how to do. And we're going to use something called Desmos to do this. So Desmos is an online calculator. You can go to desmos.com and that will take you to a Desmos calculator. When you go to desmos.com, just hit the start graphing button and it will take you to the calculator. You can also get an app on your iPhone, on your iPad, on an Android phone. There's a Desmos app. It is free. Also, our guru, if you go to the very bottom where the apps and calculators are located, the very bottom tab, there are 3 Desmos calculators. The last calculator, I believe, is the graphing calculator. And that's the one you would want for this. So various places to find the Desmos calculator. All of them are free. Yay, we like free, right? So here are the steps. Okay, I have these written out. Okay, so these are the things that I'm going to be doing on the screen. But you can come back to this slide and you can write down the steps so you'll remember how to do this. Okay, so I'm not going to go through these yet because they're not going to make a lot of sense to you if you don't see it happening. Okay, but I just want you to know that this is the slide that you're going to go back to write down what those steps were. So I'm going to open up Desmos. This is what Desmos basically looks like. Depending on how you're opening up on the computer, on your phone, it may look a little bit different, but it has all of these pieces. Okay, so the first thing that you're going to do when you want to find a regression equation is you need to plot the points. Okay, and Desmos will do this for you fairly quickly. So what you're going to do is over here on the left-hand side of the screen, you will see a plus sign. Now, the plus sign may be, like if you're on a phone app, I think it may be at the bottom instead of at the top. So just look for the plus sign. And when you hit the plus sign, it gives you options. You can add an expression, a note, a table, a folder, an image, lots of possibilities. We're going to add a table, so I'm just going to click table. So again, I hit the plus sign, and then I chose table. And you will see we have a table that's popped up. We've got an X column and a Y column. So in the X column, I'm going to type all of the house values. So I am going to do that now. So I'm going to pause the video on my end so I can type these in. Let me just type in a couple numbers real quick to show you how it works. So 25, 21, enter, and then it'll go down. You can type in the next one, 25, 55, enter. You just keep going. When you're ready to type numbers on the right, you just click over on the right-hand column and you put those in. So I'm going to pause here, and you put the numbers in from that first, one of the first couple slides where we had those numbers. Let me just show you where we're getting them from. They're right here on the next slide, actually. So they're actually in several places. So this are the numbers we're going to type in. So I'm going to pause it so I can type them in. You type them in. When you're ready, unpause it, and we will move forward on to how to find this equation. Okay, so I have the numbers in. So again, we hit the plus sign, we choose table, we enter the data values. So now when you're ready to find the regression equation and also the correlation coefficient, because you actually find both of them at the same time, you are going to click the box that says number 2 beneath the number 1 we have here. So if you look on the very left hand side where we type the table, you'll see a 1. Underneath that, you'll see a 2. So hit the 2 and it'll go down to the next box. And so you can enter something new. And so what we're going to type in may look, well, hopefully looks somewhat familiar. Hopefully you're familiar with slope-intercept form, y equals mx plus b. So it's going to look similar to y equals mx plus b with a couple changes. So if you do not have the keypad, there should be a little keyboard icon somewhere on your screen that you can click on if you need it, if like you're doing this from an app. So that you can start typing things in. So what we're going to type in, and this is on that slide, is y1. And the reason we're using y1 is because, if you look at our table, the y column is labeled y1. All right, so after the y1, instead of typing equals, you're going to type the tilde mark. So on your keyboard, it's usually the button to the left of the 1 button at the very top row, but you'll have to shift to get to it. If you are using the Desmos keypad, you'll hit the ABC, and the tilde mark is right next to the comma on the bottom row. So the tilde mark is that little squiggle. All right, so hopefully you recognize that. And then, again, we're typing a version of the y equals mx plus b. So we're replacing the equal sign with the tilde mark. So next is going to come m. And then x, so again, we have to identify the x. If you'll look up, if you look up here, our x is labeled x1 rather than just x. So next to the x, I'm going to go back to my numbers and type a 1. And then after that, y equals mx plus, and then we need a b. So I'm going to go back to my ABCs and type b. And then look what happens. Now you have to have the ones next to the y and the x, but look here. Sorry, I need to plug up my computer. But look here in our number 2 box. Underneath the y equals mx plus b, we have several things going on. We've got statistics, we've got r squared, and then we've got r. Look what r is. R is our correlation coefficient. It's 0.9006. And then we have m and b. So real quick, I want to show you, we've got everything we need for the equation. Real quick though, I want to show you, I can't see any points. There's nothing on here. And that's because the points are in the thousands. The x's are in the thousands and the y's are in the hundreds. So I'm going to go over, and there's a wrench on the top right of the graph screen. So I'm going to hit that wrench, and I need to change my x-axis. See, my x-axis is going from -10 to 9.7. I want to go from the smallest x is 2521, so I'm going to type in 2500 as my minimum x, and my maximum x was 3198. So I'm going to go to 3250. Now you can decide what numbers you want to be for your minimum x and your maximum x. Just make sure that they fall outside of the x's you have in your table. So no, you need to go smaller than the lowest x and higher than the highest x. And the same thing with the y. So what is the smallest y? So I'm going to go to y-axis, and the minimum for the y-axis, the smallest was 400. So I'm going to do 350. And the y's, the highest y I believe is 488. So I'll maybe go to 550 or 525. And I just want to show you, this is the points. Looks like the scatter plot we had on the earlier screen. And then when you did that equation, this line here has now popped up. So that is that trend line that I kept drawing. That's exactly where it falls. I was guessing where it is, but this is actually where it is. And it is the equation. What you're going to do is you're going to fill in the m and the b into the equation. So this equation is y equals 0.099198 x plus b, and b is really 160.194. And you'll just need to pay attention to how you need to round this. So, oops. I've rounded here to 3 decimal places. So y equals 0.099x plus 160.194. All right. So again, if you go back here to this screen, go through the steps. You hit the plus sign, you add a table, enter the data into the table. In box 2, you type in y1 tilde mx1 plus b, and then once you have that, you have your equation. I mean, the only other thing that I would say is you may need to adjust x min and max and y min and max by clicking the wrench. And you would do that if you can't see any of those points being plotted. It's because the window is in the wrong location. You need to adjust the minimum and max x and the minimum and max y by clicking that wrench. And then, everything else is just typing in that y1 tilde mx1 plus b, and then filling in your m and b and identifying your r. And so again, we filled in y equals mx plus b. We filled in the m, which was 0.099 if you rounded to 3 decimal places, and we filled in b, which is 160.194 if you round to 3 decimal places. And that's it. That's how you find the regression equation and the correlation coefficient. All right, so we have one more example. It says a random sample of 11 statistics students produced the following data, where X is the third exam score out of 80, so it's not out of 100, and Y is the final exam score out of 200. Find the regression equation, and I'm going to say and the correlation coefficient. So again, I am going to pause here. I'm going to go to Desmos. I'm going to X out my old line and my old points. And I'm going to do this again. I'm going to add a table. I'm going to enter the numbers from this slide. So you pause as well. Go ahead and put those numbers into Desmos. And when you're ready to find the equation, unpause the video. Okay, so here we have the numbers in the table. Hopefully you have that as well. And then we're going to find, oops, actually we can't see the points. So I'm going to go to the wrench and I'm going to change the lowest X. Looks like 65, I believe. So I'm going to go to 60 maybe for my lowest X. And my highest X I'm going to make 80. Because the highest X I believe was 75 if I'm not missing one. So I'm going to go just a little bit higher than the highest, a little bit lower than the lowest. For the Y's, the lowest Y was maybe 126. I'm going to make my lowest Y 100. And my highest Y I think is 198. So I'm going to maybe do 220, 250, something like that. The point is you need to be able to see it. So a little bit higher than the highest Y. All right, so I'm going to hit my wrench again. And there we go. Just so you know, you can click on the little, if you click on the gear wheel at the top, it's the gear wheel that's, you can see my mouse right there. If you click this, you can then click on, it lets you edit, and so you can click on the little the little green circle next to the Y, and you can change the color of your points. So maybe I want to have purple points. So now they're purple, or red points, or black points, or orange points. I'm going to keep it orange. And when you're done, you just hit done. And then let's get to the equation and the correlation coefficient. So box 2, y1 tilde mx1 plus b. And it looks like the equation is y equals 4.82739 for the m, x plus b, and b is negative 173.513. The r is 0.6631. So our equation is y equals 4.827, I'm going to round to 4, x plus negative 173.513 if I round to 3 decimal places. And then the r was about 0.6631. All right, so if we were looking at a number line, here is 0, here is 1, here is negative 1. 0.66 falls a little over halfway. Not quite, not exactly halfway, a little more than halfway between 0 and 1. So I wouldn't necessarily say that this is a strong correlation. It is a positive correlation, though. So I would say it has a positive linear correlation. A word that you can use if it's kind of like that midway is to say that it is a moderate. So it's not strong, but it is a moderate linear correlation. I wouldn't go as far as saying that it's a weak correlation because it's not super close to 0 either. It's actually closer to 1 than it is to 0. So there is a positive correlation, but it's only moderate. It's not strong. Okay, so that is all I have for correlation and regression using Desmos. If you have questions, please let me know.